The Autoflight system on the A320 family is designed to reduce pilot workload, enhance safety, and optimize performance. You should have a good understanding of the Autoflight system and how to use it, so that you can operate the aircraft safely and efficiently. This module is an introduction only. You will see the principles covered in more detail and look at individual components of the system in later modules. Then you will study the use of the system during a normal flight. Let's begin by building up a basic conceptual idea of the Autoflight system. The Autoflight system can be thought of as consisting of four main sections. At the heart of the system is a computation and processing section, the brain. The central processing section has access to several information sources. The pilots have access to the central processing section via input devices. Finally, after computation and processing, commands are provided to output devices. For the Autoflight system on the A320 family, computation and processing is done by two Flight Management Guidance Computers, FMGCs. The two FMGCs are identical and normally work together, so for training purposes, we will group them as the FMGCs. The FMGCs receive navigation information, which contains details of airfields, nav aids, airways, routes, waypoints, procedures, SIDS, stars, approaches, missed approaches, etc. Aircraft performance information, the Air Data and Inertial Reference System, ADIRS, and the Global Positioning System, GPS, for position and dynamic information. The clock, radio navigation information. The pilots provide inputs to the FMGCs using two multipurpose control and display units, MCDUs, a single flight control unit, FCU. The FMGCs provide outputs to the flight control computers for pitch, roll, and yaw control, the autothrust system for thrust control, the EPIS system for the display of information, and the navigation radios for the automatic tuning of radio aids. The FMGCs are divided into two main parts: flight management, flight guidance. The flight management part of the FMGCs controls the following functions: navigation, the accurate position of the aircraft and the capability to automatically follow the programmed flight plan; flight planning, the flight plan computation; performance optimization, cost, speed, and altitude optimization; predictions, the accurate estimates for waypoints, altitude, speeds, fuel, and arrival times; display management, the control of information to the EPIS system to display autoflight modes and navigation information. The flight guidance part of the FMGCs provides commands to the flight control computers to control pitch, roll, and yaw through the autopilot; auto thrust commands to automatically control thrust; flight director commands to the pilot for control of pitch, roll, and yaw. So far, we have grouped the two FMGCs together for our basic system description. Now let's look at the actual layout. As a general rule, the two FMGCs have access to the same information sources and exchange information. Each FMGC is linked to its own MCDU. In addition, both FMGCs are linked together by a crosstalk bus. In this way, information from either FMGC is immediately shared with the other FMGC. The inputs from the FCU are fed to both FMGCs. FMGC-1 provides information to Flight Director 1 and Autopilot 1. It can also provide information to Flight Director 2 in case of failure. FMGC-2 sends information to Flight Director 2 and Autopilot 2. It can also send information to FMGC-1 and Flight Director 1. Both FMGCs send commands to the autothrust system. The autothrust system has two channels, and depending on which FMGC is the master, the associated autothrust channel will be used. Now let's locate some of the most important components in the cockpit. The controls and indicators found in the cockpit are 1. Flight Control Unit, the FCU. 2 Flight Control Director push buttons located on the EFIS control panels and the associated EFIS displays. 2 Multipurpose Control and Display Units, MCDUs. 2 thrust levers, mainly interfaced to autothrust.